Okay, balancing formulas becomes only slightly harder when the charges don't match up perfectly. For instance, let's look at when potassium reacts with sulfur. Okay, potassium most commonly has a charge of +1. Sulfur's charge is -2. Now, in the demonstration before, the charges were exactly the same but opposite. Here we have opposite charges, positive and negative, but they're not the same. This is 1 and 2. So if we were to just put them 1 to 1 on the seesaw, remember we're picturing the seesaw again, well, it would not be balanced. The potassium will be way up in the air because the sulfur has a charge of 2 and the potassium has a charge of only 1. So this is not balanced if we just put them together. So what you want to do is you want to try to put them in a way so that this seesaw will even out. And you know, common sense tells you how this would work. Potassium's charge is +1, sulfur's is -2, so it's obviously going to take 2 potassiums to equal 1 sulfur. If you want to picture the seesaw, you picture, potassium, potassium, it's +1 and +1, and then on the negative side, over here would just be that 1 sulfur with the -2. So, +1 and +1 is a total of +2. So it's going to take 2 potassiums to balance out this heavy sulfur with its -2 charge. And so this would be written K2S. This little 2 is called a subscript, and we put that there to denote that there are 2 potassiums for every 1 sulfur. Of course, it's the understood 1 here. Now, this is not the way we're going to be doing these problems. We're going to take this process, this common sense process, we're going to make it mathematical so that we can really make it quick. And I do this with the least common multiple way. So let me show you how to get the same exact answer but using the math instead of the common sense way. This is just showing you how to think of it in your head. So let's go back over here to our potassium and our sulfur. What you want to do here in problems like this, you want to draw a line at the top and then down the middle. Okay? And you want to think of this as your negative side and this is your positive side. And you remember from the seesaw that all my negatives and all my positives have to balance out. So you want to, your top here is your totals, and you want to make sure that they add up to be the exact same thing. So you want to think, what's the simplest way I can make these add up? Or what's the least common multiple between 1 and 2? Multiples are when you count by that number. So the multiples of 1 is just every integer. 1, 2, 3, 4, 5, 6. All those are multiples of 1. The multiples of 2 are 2, 4, 6, 8, 10. The multiples of 3 would be 3, 6, 9, 12, 15, and so on. I'm not looking for all the multiples. I'm looking for the smallest common multiple between the two. So the least common multiple of 1 and 2 is actually 2. I can make them both 2. All right, so you ask yourself, what times 1 is 2? 2. 2 positive 1s will give me positive 2. It's multiplication. Over here, what times 2 is 2? 1. 1 times -2 will give me a total of -2. I want you to notice what I've got here at the top. Positive 2, -2. It's the perfect balancing act at the top. And in order to achieve this perfect balancing act, what numbers did I need? I need a 2 by the K and a 1 by the S. So how do you write that? You would write K2 S1. Of course, the 1 is understood, so it's just K2S. All right, let's apply that same rationale to another problem, like Al, aluminum, and fluorine. Aluminum has a charge of +3. Fluorine has a charge of -1. So, what's the least common multiple of 3 and 1? 3. 1 times 3 is +3. 3 times -1 is -3. Perfect balance. So the answer is Al1, of course it's the understood 1, F3. Okay, one last example. What if we have aluminum, let's do aluminum again, and oxygen. Right? Aluminum has a charge of +3, oxygen has a charge of -2. Now if you guys don't know how I'm getting these charges, I'm not going to tell them to you in the problem. You have to look on the periodic table and see what group that they're in. All right, remember, Group 1 is positive 1, group 2 is positive 2, and so on. You need to do a brief review if you don't know how I'm getting this. And then, now let's do the same thing every time. We're going to draw a line at the top, line down the bottom. That represents our seesaw. And we want to balance both sides. So this is our positive side, this is our negative side. What's the least common multiple of 3 and 2? The answer is 6. Okay. So, 2 times 3 is 6. So that's a total of positive 6. And then 3 times 2 is 6. That's a total of negative 6. So you can see this, the charges balance when I write Al2O3. And it's that easy.